In this particular episode, I am going to repeat a process that I explained in my book of Introduction to Marine Engineering. In that book, I explain with full details the propulsion system. We analyze the propeller, we calculate the propellers according with the hull, with the length of the boat, with the weight of the boat. We analyze the strut, the flange, the stuffing box, the different type of stuffing box, mechanical stuffing box with a seal pack, or the stuffing box with bellows, the stuffing box with a graphite and a collar of a steel. Other possibility is because you have a lot of moistures inside of the stringers, and when you try to check the motor mounts, when you try to tie the bolts on the motor mounts, those bolts are spinning free. What is the meaning of that? Because internally on the stringer, the foam is full of water, and those screws are spinning free. Today there are companies dedicated to do that alignment with laser, with sophisticated tools. That's good. If you have the chance, use that system, because those systems are accurate. However, I am going to explain a simple way to do that alignment by yourself with a piece of wire and a compass, and you can verify easily the alignment of the engine. Okay, one important thing is, the first step is remove the propulsion system. Yes, we are going to remove the propeller. Immediately you remove the propeller. Immediately you remove the propeller. Immediately you remove the propeller. Probably you need to use the tool to remove the propeller that I explained in my introduction book. As soon as the flange is removed, and also the coupling is removed, right now you have access to the fiberglass and you can repair the fiberglass. In this type of accidents, not only the propeller can be affected, not only the area where the flange is located is affected, the area of fiberglass. Also, the area where the strut is located could be affected. The fiberglass around this area could be affected, and in some cases the strut is broken, and in that case you need to repair the area, repair the hull, and repair the fiberglass properly. All right, and now the element that if it's possible we don't remove is the rudder, because we are going to use the rudder in order to install an L in aluminum or steel in order to pass the wire and center the wire. This is the transmission, and now we are going to align the transmission and the engine. We are going to verify that both couplings are completely aligned, and we are going to verify that the surfaces are completely parallel. Not like this, not like this, not like this. If you have situation like this, you need raise the engine from the nose. If you have situation like this, you need put the nose, the front of the engine down. If you have the engine like this, you need move the motor mounts laterally until you align the system. In other words, you align this or this or this, moving, adjusting the motor mounts. The procedure to align butt couplings is adjusting the motor mounts. Increase, decrease with the nuts on the stud of the motor mounts, or laterally on the lateral holes of the motor mounts. And as immediately those motor mounts are properly aligned and butt couplings are aligned with a feeler gauge, you pass the feeler gauge in between both of them and you verify that both surfaces are completely flat. And you move the shaft against the coupling of the transmission and you verify that it's completely flat. Right now you can install the bolts again, you can tighten the bolts, and you can start the engine again. In some engines, in between butt couplings, some people install flexible adapters, like the adapter that you have on the screen. Those flexible adapters help with the alignment and avoid vibration and keep the engine running soft. This is basically the procedure to align an inboard engine, an inboard propulsion system.